retired cargo ship sails its final voyage toward the breaking yards at sunset. At dawn, it approaches the chaotic shoreline where ships go to die, guided by skilled pilots. The bow grinds onto the muddy beach with a final shuddering crunch. The journey is over. Inside the stripped cabin, a worker pries a teak door from rusted hinges, reclaiming the first materials. Surveyors mark the hole with yellow chalk, grading each steel plate for its next life. Bright spray paint circles the prime steel, a simple code determining its destiny and value. A worker strains to open a seized fuel valve, beginning the critical task of removing hazards. Thick, black residual oil drips slowly into a bucket, a toxic substance carefully contained. Workers drag heavy oxy-fuel hoses up onto the deck, bringing the tools of dissection to the ship. The foreman traces the first cut on a weathered blueprint. The plan is now etched in reality. A torch ignites with a violent roar. This is the sound of the ship's systematic deconstruction. The white-hot tip touches steel, instantly creating a molten puddle. The whole skin is breached. Night falls as the torch carves a vertical line of fire, trailing molten slag like fiery rain. A second worker clears the cut with a steel rod, ensuring a clean separation through the thick plate. At the hole's base, a horizontal cut begins, steam exploding as molten metal hits wet mud. The cutter continues, the torch flame hissing and the ground boiling with violent steam. Deep inside the hull, a torch cuts through a massive support beam in a dance of light and shadow. The final strip of steel is severed. A metallic ping echoes as tension releases in the structure. The colossal section begins to tilt outward, peeling away from the hull in terrifying slow motion. It breaks free completely, a multi-ton slab of steel tumbling silently through the night air. The edge strikes the earth, burying itself in the mud before the full plate slams down flat. The impact is apocalyptic, a deafening boom that shakes the ground and echoes across the yard. A massive cloud of rust and dust billows upward, illuminated by distant yard lights. At dawn, an excavator fitted with hydraulic shears approaches the fallen steel plate. The shears blades position themselves over the edge, ready for the first reduction cut. The shear closes with immense force, biting through the thick plate with a metallic crunch. A sheared rectangle falls to the ground with a heavy thud, the first brick of raw material. A mobile crane with a giant electromagnetic disc swings into position over the scrap pile. The magnet lowers onto the steel pieces, making contact, ready to be energized. Power surges. A deep thump resonates as the magnetic field locks onto the steel. The magnet lifts, pulling the scrap clear, leaving non-ferrous debris behind on the ground. The crane swings its load in a wide, graceful arc across the busy ship-breaking yard. The magnet hovers over a new clean pile, a designated area for sorted prime scrap. Power cuts. The steel pieces crash down in a cascading, thunderous roar of metal on metal. A front-load loader scoops the sorted scrap and dumps it into a waiting heavy-duty truck. The loaded truck is weighed at the yard's exit, its mass documented for the journey ahead. A convoy of trucks carries the ship's remains down the highway toward the steel mill at sunset. They arrive at the mill's imposing gate, a fortress of industry glowing against the dusk sky. A sample of scrap is chiseled off for verification, a small piece representing the entire load. The truck bed tilts, dumping its entire load into the mill's cavernous raw material bed. Inside the mill, a giant charge bucket is positioned and filled by an overhead magnet crane. The bucket, now filled with a precise mix of scrap, travels by rail toward the glowing furnace. The roof of the electric arc furnace swings open, revealing a glowing, refractory-lined mouth. The charge bucket tilts, pouring an avalanche of steel scrap into the furnace with a thunderous crash. The furnace roof seals shut with a final resounding clang. The vessel is closed and ready. 3 massive graphite electrodes descend through the roof, poised above the scrap pile. Power surges. Blinding electric arcs jump to the scrap, generating temperatures rivaling the sun. The arcs deliver radiant heat. Solid scrap melts, collapsing into a bubbling, luminous pool of liquid metal. An oxygen lance blasts pure gas onto the melt, causing it to boil violently as impurities burn. Impurities rise, forming a foaming orange-yellow layer of slag on the molten steel's surface. The furnace tilts forward, pouring the waste slag out through a side door into a waiting pot. A sample spoon dips into the molten steel, retrieving a small, blindingly bright amount for testing. In the lab, the cooled sample is placed into a spectrometer for instant chemical analysis. The readout displays the exact composition. Technicians calculate the precise alloy additions. Calculated amounts of ferroalloys rain into the furnace, fine-tuning the steel's chemistry. The entire furnace tilts on its trunnions, bringing the tap hole to the lowest point. A worker uses an oxygen lance to burn through the clay plug, sealing the tap hole. The plug gives way. A brilliant, coherent stream of white-hot steel pours from the furnace. The stream arcs into a giant ladle, filling it with a swirling, mirror-like pool of liquid metal. The full ladle is lifted by crane and transported through the melt shop, a beacon of liquid fire. The ladle is positioned over the tundish, an intermediate vessel that regulates flow to the caster. Molten steel flows through a sealed ceramic shroud, protected from air as it fills the tundish. A technician adjusts a stopper rod, regulating a thin, steady stream from the tundish into the mold. Steel flows into the water-cooled copper mold. Its surface shimmers, beginning to solidify. A semi-solid strand exits the mold and is immediately blasted by high-pressure water sprays. The solid strand is bent by rollers from vertical to horizontal, moving onto a runout table. A synchronized cutting torch moves with the strand, severing it into predetermined lengths. A hydraulic pusher shoves the cut billet off the table onto the walking beam cooling bed. The bed's beams walk, shuffling the red-hot billets forward as they gradually cool. A cooled black billet is inspected and marked with paint, approved for the next process. An overhead crane magnet lifts a cold billet from storage for transport to the reheat furnace. The billet travels on a conveyor toward the dark, insulated entrance of the reheat furnace. The door opens, revealing a hellish interior. The billet is consumed within. Inside, the billet moves slowly through intense heat, transforming from black to yellow glowing. A hydraulic ram ejects the yellow-hot billet from the furnace onto the rolling mill entry table. It enters the roughing mill, compressed and elongated by the first set of massive rolls. Vertical edging rolls squeeze the bar's sides, controlling its width with precise force. A repeater mechanism lifts and turns the bar, turning it back for another pass. It transfers at high speed into the intermediate mill for further diameter reduction. It passes through multiple stands in quick succession, each reducing and rounding it further. A flying shear crops the irregular front end of the bar, ensuring a clean, square start. The bar enters the finishing mill, where polished rollers give it its final exact diameter. The long, red-hot rod is lifted and laid in perfect parallel loops across a wide cooling bed. The chain assembly line indexes forward, bringing the last link into perfect alignment. A skilled worker threads the glowing open link into the existing chain with practiced hands. The chain moves to the welding station, the open link ready to become unbreakable. The link is precisely centered in the flash butt welder, clamped with surgical accuracy. Copper electrodes close on the link ends, making perfect contact for the immense current. Electricity flows. Resistance heats the steel ends to a blinding, white-hot plastic state. A hydraulic ram forces the ends together in a burst of molten flash, forging them as one. The current stops. The weld solidifies under pressure, stronger than the base metal itself. A trimming tool shears away the brittle ring of excess flash, leaving a smooth surface. The electrodes retract, releasing the perfectly welded closed oval link. Parallel to this, a thick steel rod is sheared to form the stud, the chain's crossbar. The stud blank is heated to orange-yellow in a small, focused induction coil. A robot arm picks up the hot stud and swiftly transports it to the waiting link. With perfect alignment, the stud is dropped vertically into the center of the link's eye. The link enters a hydraulic press. Shaped dies close around it from the sides. The dies squeeze with tremendous force, deforming the link's sides to crimp the stud in place. The press opens. The stud is now mechanically locked, an integral part of the link. The continuous chain, now dozens of links long, approaches the heat treatment furnace. The chain enters the glowing furnace, bathed in a controlled, protective atmosphere. Inside, it heats to a uniform bright orange. Its internal grain structure transforms. The chain emerges and plunges into the quench tank and an explosive cloud of steam. Submerged, the violent cooling hardens the steel, freezing it in a stressed state. It exits, black and dripping, hardened but too brittle. It must now be tempered. The chain enters a second, lower temperature furnace to be healed of its brittleness. Held at precise heat, toughness is restored, achieving the final ideal metallurgy. The chain exits and cools in air, now strong, tough, and ready for its trials. In the test area, a sample length is measured and marked for destructive testing. Magnetic particle fluid is applied to a link, preparing for non-destructive inspection. Under ultraviolet light, any surface defect gathers the particles into a glowing line. An ultrasonic probe sends sound waves into the metal, listening for hidden flaws. The chain is hooked into a monumental test machine for the ultimate proof load test. Hydraulic rams take up the slack, pulling the chain taut with a deep building groan. The load reaches its peak, held for a tense moment. The chain withstands the force. A laser system measures with micron precision, ensuring no permanent elongation occurred. The load is released. The chain settles, having passed the proof test without failure. The marked sample is cut from the main chain, destined for the destructive tester. The sample is clamped into the jaws of a massive tensile testing machine.
Proceed.
The machine pulls steadily. The chain sample deforms plastically, stretching and narrowing. It reaches its limit and breaks with a sharp crack, providing the ultimate strength data. Technicians examine the fractured ends. The desired ductile, fibrous break is confirmed. Any defective link found is marked with a bright red X, destined for removal. The approved chain is lifted and transported through the factory for final finishing. It enters the shot blasting cabinet, sealed behind heavy, overlapping rubber flaps. Inside, it is bombarded by a storm of high-velocity steel shot, scouring it clean. It exits, transformed to a uniform matte gray, free of all scale and discoloration. Preheated in an oven to ensure perfect adhesion, the chain is prepared for coating. It is dipped into a molten zinc bath, a baptism in liquid, shimmering silver. Lifted out, excess zinc drips back in thick, gleaming rivulets into the kettle. Each link is permanently stamped with its grade, size, and a unique certificate number. The chain is wound into a tight, uniform, and manageable coil for transport. The entire coil is weighed on a heavy-duty scale, its mass officially recorded. A formal test certificate, its pedigree document, is printed and signed. The coil is wrapped in protective plastic, sealed against the elements for its journey. A heavy-duty truck reverses into the loading bay, ready to receive its cargo. An overhead crane lifts the coil and gently places it onto the waiting truck bed. The truck departs the factory at sunset, carrying the chain towards the sea. It arrives at the gates of a vast shipyard, where a new vessel awaits its anchor. A shipyard crane lifts the coil from the truck and onto the deck of the new ship. Workers cut away the plastic wrap, revealing the shining chain on the fresh deck. The end of the chain is fed into the hose pipe, beginning its installation. The ship's windlass engages, its gypsy wheel gripping and pulling the chain aboard. Inside the chain locker, the steel piles up with a continuous, echoing thunder. The final link is connected to the massive anchor with a torqued and secured shackle. At dawn, the windlass brake is released. The anchor plunges into the water for its test. The chain pays out, forming a perfect, strong curve between the ship and the seabed. The tested chain is laid straight in the quality control area, ready for final inspection.
Hold it right there, looks good.
A specific 5-link section is marked with chalk for the ultimate destructive test. The main chain is prepared for rigorous, non-destructive examination of every link.
Beginning inspection cycle.
Links are meticulously cleaned for magnetic particle inspection, ensuring perfect contact. A powerful electromagnetic field magnetizes the steel, aligning its internal structure. A fluid containing fine iron particles is sprayed over the weld and crimp areas. Under ultraviolet light, any surface crack gathers particles into a glowing fluorescent line. Any defect discovered is permanently marked with bright paint for immediate attention. A technician applies coupling gel to a link for ultrasonic testing of its internal integrity. An ultrasonic probe sends high-frequency sound waves deep into the steel's heart. The probe listens for echoes that would reveal hidden voids or dangerous inclusions. The chain is connected to massive hydraulic rams in the proof test machine's strong bed. The rams begin to pull, slowly increasing tension along the entire length of chain. The proof load is reached, 50% above the chain's maximum working limit. The immense force is held for a full 30 seconds, testing the steel's endurance.
Excellent work, everyone.
Laser sensors measure with micron precision for any permanent, unacceptable elongation. The hydraulic pressure is released slowly, the chain returning to its resting state.
Prepare for the pull test sequence.
Every link undergoes a meticulous visual inspection for deformations or hairline cracks. The marked 5-link sample is cut from the main chain for destructive tensile testing. The sample is placed in the jaws of a colossal tensile testing machine for its final trial. The machine pulls steadily, stretching the sample beyond its elastic limit to failure. The exact braking force is recorded, the ultimate measure of the chain's strength. The fracture surface is examined. A fibrous, ductile brake confirms perfect metallurgy. All test results are logged against the chain's unique certificate for complete traceability. The entire batch is approved, having passed every test without a single compromise. The approved chain is fed into the roaring, enclosed chamber of the shot blasting machine. It is bombarded by a swirling storm of high-velocity steel shot from every angle. Mill-scale, rust, and heat treatment discoloration are stripped away to bare, clean metal. The chain exits its new matte gray surface free of all debris and abrasive dust. Workers conduct a final meticulous visual inspection under bright lights for any defect. The chain is preheated to the ideal temperature to receive its protective coating. It is dipped into a vast kettle of molten zinc, emerging coated in liquid silver. Lifted clear, excess zinc drips back into the bath in thick, gleaming rivulets.
Perfect, set it down.
The coating cools and solidifies instantly, forming a metallurgically bonded shield. Each link is permanently stamped with grade, size, and manufacturer's mark using a hammer. The finished chain is coiled into a tight, uniform, and perfectly layered bundle.
Proceed to berth 4.
The entire bundle is weighed on a heavy-duty scale, its mass officially documented. A formal test certificate, the chain's pedigree and passport, is printed and signed. The coil is wrapped in thick plastic, protected for its journey to the shipyard. A crane loads the packaged chain onto a waiting truck, ready for final delivery.
Anchor almost secured.
The anchor chain arrives at the shipyard, ready to begin its decades of service at sea.